So let's take a look at what is synchronous versus asynchronous and why there's an advantage to creating a asynchronous programming paradigm. So here I have a synchronous service call. So here it's going to make two sets of requests to a remote service. Here I have the first request. This request will invoke some remote service, and then finally after that returns, it's going to go to this response one. But in between, this process that's making the request has to wait for the remote service to process that request before it can continue. After the response, it's going to do some processing, and then finally it's going to send the second request to another remote service, and then finally it gets a response back. But again, in between, it has to wait for this remote service to perform the task before it can continue. So this process actually blocks twice, right? There's the first wait and then there's the second wait, both because of the remote service. So the reason why this synchronous service call is not efficient is because it has to make a request to a method and then it has to wait for that response. So that can be resource that could be used to do other things. Inefficient in a way that this is a linear workflow and each one of those requests has to wait for a response. So let's take a look at some pseudocode that illustrates this example. Here I have this method called remote service, which actually invokes the remote service with passing in a request and then getting back a response. So here I'm doing this twice, and then after that I have this compute method which takes the response 1 and response 2 as a dependency and returns a third response result. So obviously in this case you have to execute these two remote service calls before you can call the third statement for compute. So let's see how we can restructure this to be more efficient. So as we said in the beginning, here we have this linear workflow which has waits in between the request and the response. But what if we can restructure this workflow so then we can issue the requests before we wait for the responses? So in this second diagram, you will see that you can make the request first for the request 1, and then at the same time you can also send the request for the second service call immediately after the first request. In that case, you can avoid this wait apparent in the first diagram. By the time that you send the request 2, hopefully the remote service for the first one already respond with the first response, and then you can do some processing of that the first response, and then by the time you finish the processing the response, you are ready to process the second response. And in this case, if you were to reorder the request, you can actually avoid waiting for the response. And that's how you can make it more efficient. You can make it more efficient by changing the way that you do the workflow and try to avoid the waiting. So let's take a look at pseudocode that can illustrate how we can implement such a workflow. Right, so now I'm going to have a different function called remote service async. Instead of returning the response, it's going to return some future object. And this future object will block until it can get a response. So here I have two calls. The first call to using request 1 and the second one, async call, will use the request 2. And both of them will return a future 1 and future 2. And then from those futures, I can get the response. In this get response, if the reply response is not ready, it will block. So in this case, I'm going to get the response 1. After I call get response, it will return response 1 or it will block. And the same thing with the future 2. This get response will return either a response or it will block. And in both cases, I have to pass those responses to the compute method. So here, since I am using an asynchronous call, it's more efficient because I can issue the request first and then wait for the response later. So I don't have to block for the response with each call.